Hello everyone, I decided to finally jump onto the Rust bandwagon and learn it a bit, and I kind of googled and found like this rustlings thingy, and basically it kind of gives you like basic exercises that you can learn Rust from. I think I decided to kind of make videos on me doing them. I kind of read their page, basically what it says that it gives you exercises, and it also gives you like a tool you can use to kind of check them. And to install it, we need to do like cargo install rustlings, and I already have it installed. And also what we need basically, we need Rust analyzer. So it will give us like code hints and everything. And we also need Rust Clippy, and I have like all that installed. We can start doing rustlings by doing rustlings in E. Gonna ask us is like this directory name is okay, and then we're gonna create it, like copy everything there. Then if we like changing directory into this newly created directory, and we're just running like rustlings. So if this is your first time, don't worry, rustlings is made for beginners. We're going to teach you a lot of things about Rust, but before we can get started, here are some notes about how rustling operates. Basically it said that so these exercises usually contain some compiler or logic errors which cause the exercises to fail compilation or testing, and it's our job to like fix them. And so we need to use text editor to search for the exercise file and open it, and we can also like do hints with H. And if like we're completely stuck, we can open an issue on GitHub or check their Q&A and everything like that. So let's start. It gives us like the first exercise, and also gives you like the solution you can check, and you can list all the exercises, and you can ask for a hint, you can quit. Okay, so I think we are ready. I'm gonna use this like browser window, because you can use a text editor to, I don't think I'm gonna use text editor there, but basically it provides you with like readme files for each exercise. For example, we go into like the intro ones, and the readme file kind of provides you some like links to the Rust language book where you can read information to help you with solutions. So we can just kind of open these links, I guess. And there, just like a hello world example. You can also read on like formatted print. So basically what it says that there are macros defined in like std-fmt, and you can use format to write formatted text, print to like print it out, so not just format a string but like directly print it out, and println like adds a new line, and you can use like eprint to print to the std error, and gives us examples. What can we do with this? Okay, so I'm gonna use this window for my code editor. I'm gonna use Helix. I can check like hx health Rust, and gonna says that it found Rust analyzer, and I have highlighting and everything enabled. So let's see what's the first exercise. It's gonna be intro 1. I already did a couple of the first ones, but yeah. Okay, so basically after we save the file, it will check it, and we can proceed to the next exercise by doing next. Okay, so here in the intro 2, it gives us a compilation error, and it says that we can't find macro print line, and we need to fix it. Okay, let's check this out. Okay. So fix the code to print hello world. Mainly considering that there is only print ln macro, we just need to do this. It should compile. Okay, so we did our first exercise. We can go to the next one. It can find a value x and suggests us to like use let keyword. Let's see. Okay, variables immutability. Okay, so by default variables are mutable, and you have an option to make them mutable. Okay, so this is like how I create a variable. Use like let keyboard, and it gives us an error because it's like immutable by default, and we try to change it. So next it tells us that we can like add a mute keyword to make it mutable, and it's gonna compile now. Okay, so let's see. Okay, add a missing keyword. Simple enough. Okay, next one. It says that it doesn't know the type, so it creates variable x, but we don't really put any value, nor do we give it a type. Basically, it's just to like specify the type. Probably not gonna work because if I just give it a type, let's say like I32, now it has like a new error because it isn't really initialized at this point. So like only option is to give it a value. So if I give it like 10, okay, it says like x is 10, and like set it to like 3. X is not 10. Okay. So we can like go to the next exercise. Now it says that, so we create a variable, but then it's not initialized at this point, and it suggests to like give it any value, I guess. So we can just give it a number like this, and yes, pretty much it. Okay, to the next one. Can assign twice to a mutable variable. It's basically the error that is displayed in the Rust book. And to do this, we need to like set a mutable keyword. Okay, I mean they just copied it, I think, directly from here. So we just need to make it immutable. And now it should compile. Good. Okay, smash types. Sort of expected string, but found integer. Okay. Fix the compiler error. Don't change this line. Okay, so it's previous exercise. So we need to like open this one. So it wouldn't like let us change this line, but then it like allows us to change this one. Okay. And I mean, what I know is that in Rust, okay, they have a concept known as shadowing. By the way, like I don't know if I taught it before or not, but I didn't really like know Rust that much. Only like basic stuff, like maybe like creating variables and maybe like doing some vectors, and like that's it. So I think we pretty soon we're gonna jump to a territory that I'm not really familiar with. But basically there is a concept known as shadowing, and it allows us to create variables with the same name but different ones. So here we have like a variable number type string, but we can create like another variable number of type integer. Okay, it's gonna compile. I think we also can like check what kind of hints it gives us. So yeah, it refers to exactly like this topic. So we learned how to make immutable variable mutable. Okay, doesn't help us if like we wanted to assign it to a different type. We can use shadowing for this. So let's check out like the solutions. I think it's this one, right? Yeah, just use a slide to create a new variable. Okay, so let's go to the next exercise. So I think what it does is basically, so constants like immutable variables, values bound to a name, and we can change them. Okay, so we can create mutable constants, makes sense. They're always immutable, makes sense. And you use the const keyword. And okay, the values must be annotated, so we need to give it like explicit type. I think you like can't really shadow constant, can you? Doesn't really say it there, but we can like try it out. Okay, so we need to go to the next exercise, and basically we'll compile because it wants a type. Okay, so we can give it like type by 32, and it will compile, right? Yes. Actually, I'm interested if we can like shadow it. Will it work? Okay, so you can shadow constants. Makes sense, makes sense. You do something like... Okay, can do this. Okay, this makes sense. Now we're gonna jump to the next topic, I guess. It's gonna be functions. Okay. Cannot find function, call me. Add some function with the name call me without arguments or return value. Let's check what kind of readme we have. Functions. Okay, main is a function, of course. And this is how we can create a function. You can give like parameters. We can also give it like return types. And it wants us to create a function without any kind of parameters and then the return values. It's gonna be like just that. Okay. Now it wants a type. There is another error I don't quite understand yet. Add the missing type of the argument. Yeah, okay. So it'll be like type pi32, right? And now I'm gonna compile. Okay, pretty easy. Argument 1 of type here 8 is missing. I mean, use basically means like unsigned 8-bit, right? So 1 byte value. Basically what it wants us to do, it seems, is to give it some value. Let's give it like, what's gonna happen if we like overflow? Okay, that does not allow overflow. It's pretty neat actually. At least on like literals. Okay. So it wants us to give it a return type. On this third one, and then this one. Stores having a say over the price is an even number, you get 10 RSBucks off. But if it's an odd number, it's 3 RSBucks off. Don't worry about the function bodies themselves. We're only interested in the signatures for now. So we need to fix the signature. Okay, so we have like I64 and we just like modify the value. So it seems we need to like just return like I64 back, right? Pretty easy. Okay. The last exercise on functions. Implicitly return smash types. The function body without changing its signature. Okay. So I think what it's like trying to tell us is basically in Rust so you can return a value explicitly by using the return keyword. However, there are like things that as so there are like expressions. Okay. So basically, if some kind of expression in Rust it returns value, like num, like times num, gonna return something. If we like don't put a like semicolon, basically make it a kind of instruction, right? It's just gonna like return this. So basically, it's the same. Okay. Let's check out the hint. So this is a really common error. Expressions and statements. So like this is an expression. It returns some kind of value. And statement, it's just if you like put a semicolon, it's gonna be an explicit expression, right? Oh no, an explicit statement. Okay. Right. Okay, let's go to the next one. So now we're going into the kind of like branching, right? Control flow. Expression allows to branch your code depending on the conditions. So we start with keyword if, we follow it by a condition. Nothing like really new there. Okay. Complete this function to return the bigger number. If both numbers are equal, any of them can be returned. Okay, so basically if A bigger than B, I'll give it like A, okay, and else give B. I mean also like we can just do it without like else, with like something like this. Explicitly return A, and then you say do this. Okay. Never used. I mean, let's run some tests, right? Okay. So let's see the solution. I mean, you can do it like this. But a thing like this makes more sense. I mean, to me. This look kind of ugly, I guess. Oh, anyway. Okay. And like the error doesn't tell me anything. So we kind of returned the wrong type. But let's check what it actually does. Is compiler error. Okay. Calling foo is fees with the argument fees should return foo. Okay. And so if we give it like foo, okay. If you give it like fuzz, we're gonna return bar, and for anything, we're gonna give like bass. So if it's like fees, we're gonna return foo, and I guess this equals to like bar, right? No, it's equals to like fus plus return like bar, right? And at the end, for other cases, return like that. Okay, let's see solutions for this stuff. Okay. Let's do the next one. Compatible types. Okay. Let me change the expression below. We like tests. So what it seems that like it kind of tries to match animals to like their locations, I guess. Why do we need this? Okay, so we like set the identifier with this stuff. So I guess like for gopher, we're gonna give it like 2. For snake, we're gonna give it 3, right? And for anything else, we can give it, I guess like anything else, right? I'm gonna work. Okay. Yes. Okay, next one. So, quizzes. This is a quiz for the following section: variables, functions. Mary is buying apples. Price of an apple is calculated as follows: an apple costs 2 rest bucks. However, if Mary buys more than 40 apples, the price of each apple in the entire order is reduced to only 1 rest bucks. Write a function that calculates the price of an order of apples given the quantity put. So we need to write a function. Okay. So it seems the apples gonna be integers, right? Or maybe like apples count, because so we return the same type. And so if more than 40, if apples count is more than 40, then we return apples count, but else we return apples count times 2. Okay. And now we go into the primitive types. Cannot find this evening. Okay. Let's check like what the readme tells us. There's a couple of basic types that are directly implemented into the compiler. Okay. Data types. Certain data type. Statically typed language. Okay. Compiler can usually infer the type. Based on the value, but sometimes it's not possible. Okay, in cases when many times as possible, such as when we convert string to numeric type using pairs. Okay. So there are cases when it can be like different types, right? So we use a parse macro, and we need to like specify the type directly, it seems, otherwise the macro will fail. So like if we give it like u32, then the parse will try to parse u32, right? Okay, so we have like scalar types. Basically something like numbers, I guess. So like integer types. Then we have number literals. Okay, floating point types. Float 32, float 64. Boolean. Character type. So the char is 4 bytes in size. It can contain Unicode. Okay. Compound types, tuple. Array. And that's it, it seems. So what's like the exercise? Okay. Okay, I can't find the variable. Okay. So define a Boolean variable. Just the name is evening before the if statement. The value of the variable should be opposite of is morning. Okay. It is. So we like check how to like change the statement, right? I think it's something like this, usually in most of the languages. Okay, looks good. Yes. Next one. Can find by ID or character. Single quotes different from the double quotes. So single quote is a character, right? And first initial is alphabetical, alphabetical is numeric, numeric. So we get like given a character, we can check if it's a letter or if it's a number, I guess. And analogous to the example below, declare a variable called your character. Try letter, try digit, try special character. Okay. So we declare like your character. Try letter. Okay, let's give it like letter L. Alright. Let's try like Russian letter. Oh, okay. Actually, it checks that it's an alphabetical letter. We can give it a number. We can give it like minus sign, right? Okay. What if I give it something like this? Okay. We can give it like emoji, right? I don't have like emoji really, I'm just gonna copy this one. Okay. So it was like primitives 2, and now we're gonna do primitive steps 3. Create an array called A with at least 100 elements in it. At least 100 elements. There must be a way to create an array as a given size, I guess. To write an array, you can initialize an array containing the same value for each element by specifying the initial size. So specify a value and then give it a size. So we can do something like, I guess, let A equals, we're gonna give it like 0, and we need like at least 100, so let's give it like 105. Okay. Let's check the solution. Okay. Something about slices. Can optionally experiment here. Get a slice called nice slice out of the array A, so that the test passes. Okay, slices. Does it even like tell you about slices there? Oh yeah, I think there was like second link. Well, slices. Slice type. Oh, it's a reference. Okay, to a sequence. So we create a slice like this. So we need like 2, 3, and 4. Alright. So like 2 is index 1. So it includes the first one. So it's gonna be 1. And it doesn't include the last one. So it's like it's gonna be like 1, 2, 3, and 4. It's gonna be like 4. Okay. Size of the value of type. Oof. But I think it kind of created an array, or what? I think you can create like a range like this or something. But for slices, I mean, you should like explicitly use like this sign. It seems should be good, right? Yeah. Let's check out our hint. Okay. Basically, it tells us to read this stuff. Oh, whatever. I can find a name. Not found, not found. Okay. The structure the cat tuple in one statement so that the println works. I think it talks about tuples there. And the structure in tuple. So I can do like this, right? Do like name, I guess, age. It should work. Right. Cannot find wait a second. Okay. Use a tuple index to access the second element of numbers and assign it to a variable called second. Okay, so we can like index tuples like an array, and okay, tuple index second element, so second element gonna be index number 1, right? Do you index tuples differently? Oh, you index tuples like with a dot. Okay. Look good. Local variable with a similar name exists. Can find v. So now we'll do like vectors. Create a vector code v, which contains the exact same elements as a use the vector macro. So, like this is an array, and we need to make a vector. Basically contains elements from the array A. Okay. I actually don't know how to do this, by the way. So now we're gonna learn. I'm gonna check out this one. You can create a vector like this. And we can use a macro to like give it some elements. Okay. This is an array. And maybe we can do it like let v equals no, can do like this. The exact same elements as A. Okay. The exact same elements. The second way is to use okay, maybe it just wants us to like write them out like manually. It seems like this. Let's check the solution. Yes, just like had to like write them out manually. I was overthinking this. Okay, let's do the next one. Oof. Okay, let's first check out the exercise itself. There's a lot of stuff actually. Harris is also want to multiply each element in the input slice by 2, but with iterator mapping instead of manually pushing it into an empty vector. This is an example on the function map example. Example of collecting a vector after mapping. We map each element of the input slice to its value plus 1. Okay. Like, from what I know, like those kind of things, they're like lambdas in Rust. So basically we like take a vector make iterator out of it. We like we map it to some kind of lambda, and we collect a sync. Yeah, won't give me docs. Why? Okay. Well, no definition. Whatever. So this is a for loop. Okay, so we create a new vector. We can like push into it. Multiply each element by 2. So this is like it's a naive approach, I guess. So I have like an output and push stuff into it. And push like this, right? This should be good. Can do something there. It's gonna do like this, whatever. It's intentional. Unused variable. Should give us errors, right? Doesn't give us any errors. So we do fail the test. We didn't use map, right? And to not fail the test, we need to basically return something. We need to return an element. I also need to like make it not fucking ugly. Okay. This looks better, to be honest. It also looks like this, it seems. Okay. Did we pass? We did pass, right? Or didn't we? Okay, we did. Next one. Move semantics. It's kind of the famous trust thing where barrel checker and everything. Okay, so what's there? So we shadow the quack with whack. Okay. So I need to make it immutable, right? I mean, the fix is easy. The most used Rust data structure. Arrays. Okay. Make both vectors 0 and 1 accessible at the same time. Guess what happens is so we have a vector, and then we like add some values, and we create a second vector, right? I mean, it kind of seems to me we want to have like two vectors. But I guess what we want to do is like this. Didn't change anything. So yes, a moving variable, right? So like we put like this vector, we put it like, so this vector, we put it there. And so it's like gone. Like this is a garbage variable, it's unusable. So it's like there right now. But we need 2 copies, right? Cloning. Make another separate version of the data. What the fuck do I make a separate version? Well, I guess we could like read for once, right? Okay, if I make a copy, right? And moving occurs, it suggests us to use clone. Oh, okay, I think I remember now. So basically what happens by default is in Rust, when you do like wag equals to wag, it just kinda moves the like this variable. Now it's here. So like was here, and now like this becomes unusable, and now it's here. But if you wanted to create a copy, you would need to do like, right? Or not right? Or does it only work for like strings? Doesn't give me any errors. I did clone it, right? No, I did that. But Alex moves here. Okay. Oh, okay. So before moving in, yeah, I see. Sure, like. Well, I guess we want to do it like this. Not like this. So we need to like move that. Okay. So yes, like set us to use clone. Makes sense. And then what I'm gonna do, I think I'm getting tired by this point. It's almost an hour. It's almost an hour. Use a compiler error in the function without adding any new line. We can just make it mutable here, right? Easy. Let's check the solution. Okay. Looks good. Let's move to the next one. Fix the compiler error only by reordering the lines in this test. Don't add, change, or remove any lines. How it happens? Can borrow X as mutable more than once. Okay. So basically let Y and Z, they're like two mutable references to X. And we can't really do this, but it says that we can't change or remove any line, which is kind of strange to me, because how we do it there? Well, I guess you do it like this, right? Okay. Okay, makes sense. So even if we like technically have two mutable references, we don't use like Y anymore. So basically compiler doesn't complain. A lot of errors. Let's see first what it wants from us. Is a compiler error without changing anything except adding or removing references. Shouldn't take ownership, should take ownership. I mean, this is easy then. So we have like data and it creates a string for us. And get char shouldn't. So we like give it a reference. And there we do like this. Well, didn't. Okay, so if we assess a reference, we need to asset as a reference, and we need to not pass it. Okay. Okay. Still kind of weird. So. But I think you can have a mutable reference. Can you? Can have a mutable. What's the difference? Right. Integer string. We can use the string after the go. That reference is like a pointer. Okay. So reference pointer. We can have mutable references. Okay. If If you have a mutable reference, you can have no other reference. Makes sense, I guess. Basically, kind of references, they fix stuff, so when you borrow a value, you don't have to like return it exactly. We can just pass it by reference. Well, I guess that does make sense. Alright, structs. I think we're gonna do structs next time because I'm tired already. So I guess until the next time.